Hello, you're welcome to my channel. Now in this video, we're going to look at continuity of functions, alright? So I'm going to give you here a very primary kind of definition. Then after that, we'll look at a little bit formal definition, alright? That one is a little bit rigorous for you. Okay, so a function here is continuous at a point if we can draw a curve, right? So you notice this, through that point without lifting our pen. You know, sometimes we have to plot graphs of functions. Okay, so if you can plot a graph, you will need the vertical axis and then the horizontal axis. Let's say the output is y and then the input is x, right? So when we have this, then you want to plot this function on a graph, you will need a curve. Okay, the function will be like a curve, so it can be any random structure. Now, assuming we got to this point, let me call this point A on the x-axis, and then we drew the curve. When we got to that point, we lifted our pen, and then we now draw again some other point, or through other point. Then we see that this point, right, that through this point, the function is not continuous through that point, because we can't draw the curve through that point without lifting our pen, right? But if at this point here, let's say I call this point B, we can draw it freely, okay, without lifting our pen, then we can say the function is continuous through that point B. So just by saying it's continuous, something continues without, maybe say without jumping to another point to draw, or without lifting your pen, or many things like that. Well, that is just a way you can see it, you know, from the context, continuity. Let's look at this definition in a more rigorous way. Now, in this definition, we are going to have to recall some concept of limits. Now, look at this curve. As we are getting closer to this point, right, and then we are moving away from it, just by neighborhood, by closeness to that point, we will need to talk about limits, right? So, continuity here, we will need the concept of limit, and as well, we will need the concept of evaluation of functions. So, you need to know how to evaluate some functions. Of course, we've done that already in our playlist functions, right? Good. So here, a function is said to be continuous at a point if the following happens. So let me put it down. A function, okay, f is said to be continuous, is said to be continuous at a point let's call that point C. Now observe in this other part we didn't label the point, we just wrote through a point. So in this case we will need to show the point we're talking about, all right, the reference point. So it's continuous at a point C if the following happens. Now if the limit, okay, this is how we write limit, just in short, Lim, of the function f of x as x tends to the point we are talking about here, which is C, right, exists. And then the second one is that if the value of the function evaluated at that same point also exists. And then the third one is, now if these first two are the same. But before we get there, let me look at the first one. So we have that the function is said to be continuous at a point if the limit of that function as x tends to that point exists, all right? That is, you can find the limit of the function as x approaches C, and it exists. Now, for a limit of a function at a point to exist, in one of our videos where we talked about existence of limit, for a limit to exist, we will talk about the one-sided limit, all right? That is, as x approaches C from the left, maybe let me put it down here. That is, as x approaches C from the left, and we put it down like this, C raised to the power negative, all right? Okay, and then the limit of the function as x approaches C from the right. Good. That is what it means for a limit to exist. So a limit is said to exist if the one-sided limit, that is these two stuff here, the left-hand limit and the right-hand limit are the same, right? When they both exist and they are equal, then the limit of that function exists as x approaches C. Good. And then we also go ahead and evaluate the function at that point C. We will do that by substituting the value of C into the function, and then we simplify as we did. And then when the both of them exist, and the third condition has it that when the two things, that is the limit and the function value at that point, when they both exist and are equal, then the function is said to be continuous at that point, all right? Good. So this third one here is what is really, in fact, is the main thing here. So these three conditions must be satisfied, but this last statement here, which tells us that the limit of f of x as x tends to c is equal to the limit of f of c. So when the limits of the function exist, that is the one-sided limit, they both exist and are equal, and then we can evaluate the function at that point c, we get the same value that we get from the limit, then the function is said to be continuous at that point. Good. C, at that point C. So in the next video, I'm going to check some functions and I'll give you some points or reference, all right? And then we are going to play around with this formal definition. Anyway, this one was just from the context. All right, great. Okay, thanks for watching. Please subscribe to my channel.